This topic is really kind of what I'm passionate about Chef. It really kind of demonstrates the power of what you can do with Chef as a configuration management tool. So for a lot of you, I was here last year, my first Chef conference. I was new to Chef at that point in time. I took the introduction to Chef just a year ago, and I was in your seats, and I was always questioning, hey, what can I do? What's possible? So I wanted to come back this year and kind of show you what that means, give you the tools to do it, and provide a pathway so that you can utilize some of the bigger features within Chef, and the sky is the limit. So talking about that, you know, what is possible when you're using LWRP, heavyweight resource providers, or even libraries? So I created a company called RangePro, and RangePro is an archery shop, kind of SaaS product that solves the problem of managing range time. I didn't wake up one morning and say, hey, I'm going to build this archery management product. I do have a brother-in-law that owns the largest shop in Nevada. And when he opened it about a year ago, he was managing his range time on paper. And I thought, that's ridiculous. At the time, we're in 2014. Why are you managing your range time via paper? And why are you doing all this manual steps? I can solve this for you. So they were my MVP. And I kind of had to take the stance of, I need to make this the best product with the least amount of overhead. So knowing Chef, knowing what I can do, and knowing what I can do with lightweight resource providers, I created my own cookbooks, my own providers, and I created a webhooks cookbook. And the webhooks cookbook started out as a notification service using net HTTP as far as a class, and kind of evolved into a complete invocation of that class. So what I did is I said, okay, I can't have the overhead of managing attributes within my files or managing attributes within roles or environment files. I wanted to push that off to an API, right? So I created an API that spits out JSON that has a nice little GUI in front that I can manage which clients have are on which server. I just override that one single attribute within Scalar, and Scalar goes out and says, hey, this is the API key for this server. It reaches out, Chef reaches out to my API and gathers all the configuration information for each individual client. Now from that, I said, hey, I don't want Chef clients on each individual one of my containers. So I needed to write my own book. I needed to say, hey, I just want one Chef client that can manage up to 10 or 20 containers without that additional overhead of having multiple Chef clients wondering what they're doing. So I created my own container, and then I needed to manage the services, the packages. I needed to manage if I can execute code on those containers. So I did an override to the multi-provider of package, service, and execute. I did an override, called it my own. The apt provider I called apt-LXC. And then I was able to manage packages on those individual containers. So my wrapper cookbook that I kind of bring all this together with goes ahead and creates the containers based on their version, if the product is enabled, what level of product they have, and then I configure them, right? And then I said, hey, my build times are high. I need to go ahead and minimize this as much as possible. So I used a little bit of Ruby, and I implemented threading so that I could create threads of creating individual containers all at the same time. I'm still doing performance. There's a little bit of a caveat there. Still doing some performance testing. But preliminarily, it shows that I can save a lot of time on my build times by doing threading with Ruby, creating these containers and configuring them. So we're going to jump right into it. I did write for lightweight resource providers, I did write a Kickstart cookbook that you can get on the supermarket. That has comments like no tomorrow. So it accompanies a blog post, LWRP an introduction. It accompanies a blog post. So download that cookbook, look at the blog post. We're going to cover a little bit here. Look at the blog post, and it follows right along with that. So you can have the comments. If you have a question about why you're doing something while looking at that cookbook, it already has the comments in there about what's happening. Now, when would you want to use lightweight resource providers? What is applicable? So you're used to using recipe DSL, right? You want the more capabilities of lightweight resource providers, but you don't necessarily want to use heavyweight. Chef did provide a nice DSL now that you can get the benefits of writing providers with their DSL. So it's going to have a little bit faster development, which is perfect, right? Can get you going as quickly as possible, doing what you need to do. If you want to go beyond the Ruby block within your recipe code, the Ruby block has its limitations, right? You can actually invoke a lot of Ruby in your lightweight resource providers or even your heavyweight resource providers, and it opens up a whole new world for you. Now, two elements to the resource provider. You have the resource file and you have the provider file. For lightweight, it's going to be underneath the resource folder and the provider folder. They need to be named the same thing, right? And the resource is the actual input parameters. It's the attributes, what they're entering in. It's what you see when you execute, the package resource in your recipe. You're passing it a package name. You're passing it an action. That's all within the resource file. Provider actually performs the actions. It's where your Ruby code lives. It's where you can even use other resources within your provider. And keep in mind, when you're using lightweight resource providers, you're inheriting, in the Ruby world, you're inheriting from Chef Provider, LWRP base, which will make sense here in a little bit once we get into it. So here's some demo code. This is actually from the Kickstart LWRP Cookbook. You'll notice that there's really not much to it, right? We have actions that we define, create, delete. We have the default action, right? Create. If it's not defined, create will be the default action. We have a name attribute. So kickstart LWRP, kickstart underscore LWRP. Example config is what's going to be passed into that name attribute. So that first line, that value is going to be stored in that name attribute. And after that, you have several different types of attributes. You have string, array, hash, Boolean values, whatever it may be. And you just state those. Now, I'm setting the default in my actual resource file. But what I like to do as far as structure, I like to actually set the default from a node attribute in that particular cookbook that houses the provider. And what that does for you is it allows you, when you're wrapping your cookbooks, when you have a wrapper, right? If I want to override the default, if it's something that I'm executing multiple times, if I want to override the default, I can just do a node override of that attribute. And I don't have to state it every single time. Now, the attribute accessor exists. That's going to be a state attribute where I say if maybe a file exists or not, true, false, Not much to it. The one caveats is you notice my cookbook name is kickstart-LWRP. To access it in the recipe code, it would be kickstart_LWRP. And you're going to notice here in a minute when we actually instantiate the resource that it takes out the dash or takes out the underscore, and it becomes a capital letter afterwards. Now, I did name it default.rb underneath my resource folder. Default.rb enables me to only call it by the cookbook name. So if you were to say create.rb, if that were your file name, it would be kickstart_LWRP_create. Pretty simple, right? So moving on, this is the actual provider file. I have a low current resource. That low current resource method lives within the Chef Provider class. You have to override it. It doesn't actually contain anything, and Chef will actually yell at you really loud if you don't override that particular method. First thing you're going to do is you're going to create an instance of that resource. You notice that I don't have that underscore or dash in there. So if you have a dash in your cookbook, it'll be kickstart capital K and capital L on the next word. If this were create.rb as far as the file name, it would be kickstart LWRP, capital L, and then capital C create. So that's how you instantiate the resource itself. Now, a common practice is to load all the new resource values into current resource. So that's nice, but in all actuality, as far as when you're creating a resource provider, you as the coder is responsible for gathering current state. The user that's using your resource will pass you what's contained in new resource, which will be all those parameters that you've stated, right? And you need to go ahead and gather what the current state is, current resource, and then that attribute, what it needs to be. In this particular instance, I'm not doing that. I defer that off to another resource, template resource. The template resource can manage what the current state is, the desired state, and do a convergence. A good example of what I'm talking about as far as loading the current resource is on Supermarket. PHP5-FPM is a good example of that. It's completely Ruby, and I manage the actual pool files completely by Ruby, And you'll see that as an example of gathering a current state and deciding on whether I want to converge or not. The last part is setting that state attribute. I'm just looking at a file, what's passed in that name, example config. I'm looking at a file and I'm just seeing if it exists or not, and I store that within that state attribute. Not much to it. Now, within that same provider file, I need to actually define the actions. So in my resource file, it said create and delete. It's just action, the symbol name, which is create, do, and then everything underneath that is called a block, and that block is going to be passed to the DSL for execution. Now, what Chef does on the back end is they take that action create, the DSL will convert that to a method called action underscore create. So that's what's happening in the back end. Here's my state check. Typically, you do a state check before you call the converge by. Converge by is just a method that's within Chef Provider that you pass. Here's what you need to execute to converge the node. And oh, by the way, pass it this nice little message that's going to actually be displayed after convergence is complete. Now, if the state is not matching, right? If it equals false, if it's not there, go ahead and do a chef log error, but that's not going to stop Chef, right? We'll get into that here in a second. You'll notice also that I gather a response from that method that I called create, true false value, of whether it was successful or not, and I store that into a method that is housed by a new resource called updated by last action. That just states, yes, I updated the node based on this last action, and that's it. So here's my actual create method that I'm calling. Great thing about LWRP is that you can use Ruby, right? I mean, you can create as many methods as you want, and you can actually execute other resources. So in this instance, I'm calling the template resource to actually create a template. And the template resource will contain and look at the current state of that file and converge the file if it needs to. So I'm deferring those checks off to the template resource. And I'm setting it to a T variable. What the great thing is that you're getting an instance back of that resource, and you're storing it in the variable that you assign to it. So now I can call methods within that resource. And one of the useful methods is updated by last action, and that will tell you true or false if template was successful in updating that file. So these are kind of the ground basics you'll need to write lightweight resource providers. I would suggest looking at the blog post. It does go over in great detail on what you need to do, and use the cookbook. It'll give you a direction. Now, a couple of tools that you'll need. If you need to execute shell, Chef provides a mix-in called shell out. All you have to do is extend that module, and you can execute that method, shell out, pass it the command you want, and then pass it a hash value, there's actually a lot more than just returns. But basically, I'm saying it needs to return a 0 value. So if it returns 1, it's going to stop Chef. Chef's going to say, hey, what's up? It returned an unexpected value. So you may have to play with the return values based on what you're executing. Now, I just go ahead and get the output of that. I strip all the white space, and that's pretty much it. So a good example of this is the IAS cookbook. The IAS cookbook does a lot of this with the app command, appcommand.exe, to manage the IAS configuration. Take a look at that if you want to see how they accomplish it and how they parse the output. It's a great example. Exceptions. You can raise exceptions within the LWRP or heavyweight resource providers that will stop Chef. It'll say, hey, here's my exception, and I'm stopping. Beyond that, logging. Logging is passing back to the user, the one that's actually writing your code. I use a heavy amount of logging on everything that I do. Whether it's debug or info, whatever it may be, logging is the greatest because it's your debugging tool. It's how you determine what is happening within your provider. Now, if you do a log fatal, it's not going to stop Chef. You actually need to do an exit 1, return an exit code of 1, then it's a failure, and it'll stop Chef. So now, you might be familiar with recipe DSL, where you have the compile phase and the execution phase. The Ruby code within your recipes, right, if it's not within a Ruby block, is executed on the compile phase of Chef, whereas your recipe DSL, the resources that you're calling, like package, service, those are executed on the execution phase. So in the recipe DSL, how you solve that is you wrap your Ruby code within a Ruby block resource. It's Ruby_block, block new, and then the code you want to run. And what that'll cause is it'll cause Chef to run sequentially rather than executing that Ruby code first on the compile phase. So there's a couple rules that I follow with this. The first rule is that if what I'm accessing as far as Ruby, if that exists before my Chef run and is consistent throughout, unchanged, my Chef run, I do not need to have it in a Ruby block. So, but the second rule that I follow is if what I'm accessing as far as Ruby, if that is dependent on something that is happening within recipe DSL, the resources that you're calling, it has to be in a Ruby block. That's for recipe code, right? Now you have a little bit more of an option with lightweight resource providers because you have access to methods and you have access to actions. So the first one is that you can wrap your Ruby code in a Ruby block, or you can just create a nice little method and then call that method within your Ruby block in your actual provider file. The other option, the one that I like, is the compile execution is contained to the action itself. So going back to my LXC cookbook, I have a create phase and a configuration phase. Unfortunately, the create phase is I'm utilizing resources that I have created, right? That's recipe DSL. I'm executing resources that I created. And the configure phase has quite a bit of Ruby in it, not a whole lot, but a mix between recipe DSL resources I'm calling and Ruby. So what I did was I created a create action and a configure action. So now the Ruby code that I have in my configure action can run without having to be in a Ruby block, and I'm a happy camper because I like to actually use Ruby naturally. Now libraries, I'm not going to get too much into libraries. Libraries are great as far as containing namespaces of methods that you create. Webhooks Cookbook is a good example. The Webhooks Cookbook is a library that I provide, and you can reutilize that in any provider that you want to create and get the response back from your API or whatever you're calling. So libraries are great. You might notice this chef recipe send, that's called dynamic dispatch. I'm executing code at runtime with Ruby. So I'm including that namespace, that class namespace, into the chef recipe class at runtime. You don't have to do that if you create libraries. You can actually, if you're using LWRP, you can create the namespace under chef provider LWRP base. So that in my provider file, all I have to do is say webhooksns dot whatever method I'm calling. And then if I want to include that in the recipe, all I have to do is inherit from what I created up above and add it to the recipe class as a webhooksns namespace under recipe. So in my recipe code, I can just say webhooksns dot whatever method I want to call. So one of my favorite topics is heavyweight resource providers because it really opens up even more about what you can do with Chef. Heavyweight resource providers, why you would use them is to extend classes, to override classes that are native to Chef, right? How I took the apt class that is a part of the package multi-provider. I actually took that apt class, I inherited it into my apt LXC class, and then I did an override of some of the methods, and boom, I'm done. I don't have to recreate the entire thing. All I did was on the run command method, I prepended the LXC attach -n with my container name, and I'm able to execute code on my containers. So there's a lot you can do as far as at runtime with Ruby. Ruby is great with modifying things at runtime because Ruby at runtime is flourishing with all the classes that are created. You can override them at runtime. You can create new ones at runtime. The other option is to do multi-provider. And I created 2 cookbooks I'll talk here in a minute. Heavyweight Resource Provider Cookbook, the Kickstart one, actually shows multi-provider. So you can use it as an example of how to accomplish multi-provider with heavyweight resource providers. If you're using lots of Ruby, you might want to consider using heavyweight resource providers. Also, if you want custom resource names. Custom resource names are bound to the cookbook name, and the resource names that you create in lightweight resource providers are bound to the cookbook name and the actual name of the file. If you use heavyweight resource providers, you can actually bypass that and create your own resource names and not be bound to that particular restriction. There's two options to inherit from in heavyweight resource providers. There's Chef Provider LWRP base, which is where you were before. You have access to DSL at that point. So why would you want to do that? Why not just use LWRP at that point? Well, custom resource names. I can now call it something different. The other one is Chef Provider. That is no DSL. You're kind of on your own. That's how Chef started. And then they created this nice DSL for us to use. So you're basically on your own. You can either do Chef Provider or Chef Provider base. So here's the Kickstart cookbooks that I created. Kickstart, heavy, lightweight resource provider. Maybe some of you are twisting your head. What is that? That's just my terminology on what I'm inheriting from. I'm inheriting from Chef Provider, LWRP base. Heavyweight resource provider is inheriting from Chef Provider. Kickstart, heavyweight resource provider, also demos multi-provider, as stated before. Go ahead and download those. They're consistent, so it's the same operations across lightweight resource provider, heavy, lightweight, and heavyweight. So you can kind of compare and contrast what's happening in each and what they look like. So here's an actual, I'm not going to show you the resource file. I would go out and download it. What I want to show you is a provider file. So here I'm inheriting from Chef Provider, and I'm calling it my HWRP. And my HWRP is not the name of my cookbook. The name of my cookbook is ChefConf. This is available on my GitHub account, ChefConf. Go ahead and download it. Everything that I show you here works, and it actually is available to everyone. So it's the same thing, load current resource. I provide an instance. I create an instance of my resource. But you'll notice here, action_create. So the DSL in Lightweight Resource Provider is just creating these methods called action_create. So if you want to have a create action, you would do that. If I would have a delete action that I stated in my resource file, I would do action_delete. It's the same converge by method, right? I can call additional resources, but not by default. I'm going to show you how to do that. You do not have access to node attributes, but you notice at the very top, the line that I'm calling the template resource, I'm actually gaining access to the node attributes. There's a lot of documentation out there that says you don't have access to node attributes, but I'm going to show you how to do that. So, but before, let's talk about run context. So heavyweight resource providers, the files that you create are under libraries. So the libraries folder is where you create those files. Those files can be called anything. It's more about the class name that you create, and you'll see that in the two cookbooks that I provided. Now, run context loads your cookbook resources, right? It loads all the assets in your cookbook. And it starts with the libraries that you created, then next the attribute files, lightweight resource providers, definitions, and recipes. So now to access additional resources, to access recipe DSL, you'll need to include in your provider, your heavyweight provider, Chef DSL recipe. And at that point in time, you can call package, you can call template, you can call other cookbook resources. It's just not there by default, like the lightweight resource provider. Now here's actually how to access node attributes, and it has a lot to do with run context. So when you create your heavyweight resource provider, that doesn't have access to the run context. But what does is what's calling your load current resource, right? Chef itself is calling your load current resource, and it does have access to the run context. And that's what's needed by a method within the module include attribute. So I extend that module, I extend Chef DSL include attribute, I create an instance of my resource, and then I execute the method include attribute, my cookbook name, which is ChefConf, and then the file name. So now the file name, there's a little bit of a caveat. It has to be directly underneath your attributes folder. It can't be under a subdirectory called default. I haven't gotten that to work yet, but hopefully after ChefConf is over, I'll post another blog post on my blog that will update and be able to inspect those subdirectories. Now here's the methods. We had an action create, action delete, right? With Ruby, the fact that Chef doesn't really give you guardrails, it guides you, right? It guides you down the recipe DSL, but Chef by no means limits your capabilities. Like a lot of the other configuration management tools, they like to restrict you to very opinionated DSL that directs you down a path. Chef actually doesn't do that. And I don't know about you, but I get very claustrophobic when it comes to technology. I like to have the most power that I can in a configuration management tool, and Chef is there to perform. So I'm going to show you actually how to meta-program with Chef. Meta-programming is creating methods, creating classes, creating whatever you want at runtime. It doesn't exist beforehand. I'm going to create it at runtime. And what I'm going to do is I'm going to create these methods at runtime. So first, I have to have a way to check whether that file exists or not, like before. So all I did was set up a hash. I set up a hash with my actions and gave it key value pairs of exists. What it needs to be, exists needs to be false, right? And then pass a message if it's not. So I set up that hash of those checks. And then I'm passing to my setup actions method. I'm passing a method within new resource that houses all of the actions that you've stated in your resource file, create, delete. And it's just an array, right? So I can pass that as an array to my setup actions method, along with those checks as hash. And don't worry if you don't understand entirely what's happening here. I'll go ahead and explain it. So here's my setup actions method. I'm going to loop through those actions that I passed, which should be create and delete. And I'm going to use what's called dynamic method. And Ruby is wonderful at this. I can create a method on the fly that didn't exist before. And I'm calling define method, which creates that method. And I just pass a symbol of what that needs to be, what that method name needs to be. So action becomes action underscore create, and it creates that method for me. Now here's my check. Current resource.send, that's called dynamic dispatch. I can dynamically on the fly call any method with dynamic dispatch, and I can pass it as a symbol, right? So what that does for me is that all of the attributes that you create in your resource files, those actually get converted to methods. They're get and set methods. So when you call that method without passing in a parameter, it'll return the value of that instance variable within that resource class. Now, if I were to pass it a value, it would actually set that instance variable in the resource class. So all I'm doing is comparing, taking that hash value. Up above, you'll see create. Exists is the method that I need to call because that's the attribute I want to gain access to. I call that. I convert it to a symbol, and then I make sure it equals that value of false or true, right, depending on my particular action that it's looping through. And I go ahead and execute the converge by, or I call the converge by method, and I capitalize that action, nice little message there. And then I use dynamic dispatch to call another method. That method is called create. If once it loops through, it'll be create. The next one will be delete, right? And this is created all at runtime, right? I did not state this beforehand. Now what that gives you, and here's the actual create method that's called. It's same before. But now what that gives you is I only have to now, I can create as many actions as I want within my resource file, set up that hash, and I can just create these create methods. I don't need to state the converge by every time. I don't need to do the checks every time. I don't need to state the log message every time. That's already done for me. That's code writing code, and that's one of the awesome things about Ruby, and you can couple that with the awesomeness of how much power Chef gives you as far as what you can do. So now the last thing, just a little bit of fun. I'm going to do a blog post on this with definitive performance numbers with New Relic to see if there's a potential performance gain as far as my particular situation of threading the creation of those containers. What I did was, well, if I can do meta-programming, why I can do threading as well. So I added a files attribute. It's just an array of file names that I'm going to actually create, A, B, C, just arbitrary. And I just modified what you saw before. I added a threads array. I actually loop through those files, that attribute that I'm passing in my actual resource, my recipe DSL. I just loop through them. I check to see if that file exists, and then I actually just go ahead and grab what it needs to be in that hash, which is true or false, depending on what action it's looping through at that particular time. And then I created an attribute called multiproc. Multiproc just checks to see if there's multiple processors on my host. All it does is just do nproc. I use that shellout method. And if it's greater than 1, this is a one-line if. So if it's greater than 1, go ahead and create the thread calling the dynamic dispatch of that particular action at runtime that's looping through. And if it's If it's not greater than 1, just go ahead and execute the method or call the method like normal before. So kind of cool. It shows what you can do in Chef. Then I take threads out each, I wait for all the threads to come back, and I'm complete. So this is all dynamically created for me. And it's one of the great things about Chef is that there is no limitation of what you can do. So we've got about 10 minutes left. Take some Q&A. Don't worry if you don't understand everything that I covered today. Go ahead and download those cookbooks. All the cookbooks are available for you to look at. I'll be in the community room until 3:20 when I want to look at the chef delivery talk at 3:20. Twitter name is Inglorious Chef. I do watch a lot of movies, so that's where I kind of got that from. Hit me up on LinkedIn. Definitely connect. If you have any questions, it's a great way to get a hold of me. And then my GitHub account, Stajkowski, my last name, and then ChefConf is that cookbook that I just displayed at the end with heavyweight resource providers.
Any questions?
Is there any concern about polluting the namespace that Chef uses for your own libraries? Generally, I would, when I'm writing Ruby code, I try to create my own, module-based namespace and just reference it by that full name whenever I need it. Is that a best practice or is that a requirement for writing Chef, the heavyweight resource providers?
It's not a requirement. It's really more of a Ruby concern. So it is a potential problem, right? With code that is entirely a Ruby program, you're going to eventually sometimes clash on the namespace. The good thing is that if you were to create it under the provider class, there's really not much underneath that to actually cause a problem. If you're creating custom module that's underneath Chef Provider LWRP base, there's not much underneath that if I were to create another namespace under that. So it's not too much of a concern, but it's definitely something to look out after. And when stuff starts to break, you'll see the result of that.
All right. Any other questions? All right. Well, thank you very much. Can I get a round of applause?
Thank you.